Assalamu alaikum friends. Today we will study about relative extrema. As we all know, relative extrema, it has two conditions. First is relative minima, and second is relative maxima. Relative maxima. These are the 2 points when we use calculus. So if first one, so let us see the relative minima. In this, if there is an open interval containing x on which f function of x is a maximum, it's a minimum. We are talking about minimum, so it's a minimum. Then f is a function of x is called relative. We use relative minima and relative maxima, mx. So we called it relative minima. Now if or you can say it as f, or f has a relative, or the function has a relative minima at x function of x. Okay, now the second one is relative maxima. So it means if there is an open interval containing x on which function of x is a maximum, then function x is called what? Relative maximum of function f. So, or you can say that f has a relative maxima at we could use maximum here, and there we will use minimum. Will tell you why I am doing so. At x with the function function c x with the function x. So I am using minima and maxima here because the plural of relative maximum is relative maxima, while the plural of relative minimum is relative minima. These minima and maxima are the plural words, while minimum and maximum are the singular. So that's why I am using it. Now let's see the two conditions, how we denote by using the calculus. So using calculus, these two we derive in the curve by using differentiation. So the two conditions, first differentiating y with respect to differentiating x is equal to 0, this condition, this is if f prime x is equal to 0. First condition is this, and second condition is d square y upon dx square is less than 0 or negative. That means second derivative is negative. So this condition is denotes relative maxima. Now these two conditions, when the first difference is 0 and the second difference is negative, so the condition is relative maxima, while for the relative minima, now if this is for relative maxima, now relative minima, the two conditions will be first difference dy upon dx is equal to 0, means the first difference is 0 while second difference is greater than 0. So in this condition, when second difference is positive, our second difference is positive. So in this case, if the situation, if when we differentiate the two after first and second differentiation, our first differentiation is 0 and our second differentiation is positive, it means we have relative minima. There you can remember it by this, in when there is minima it will be positive, the opposite, and it is maxima it will be negative. So there are we have let's explain graphically. This is the curve x, this y, and our curve will be like this. So here we have, when this is the lowest point, so this is, we will say it as absolute minima, and this is absolute maxima, but we need to find relative maxima and relative minima. So let us see, and we have another concept also. These are the two situations when dy dx is equal to 0 and this is positive. Now the third one will be if our derivatives, if our first and second derivative is 0, so what will be the condition? It will be the point of inflection. Point of inflection is what? We know through the first difference the slope of the curve. Through the second difference we know the convexity or concavity of the curve, while through the point of inflection we will come to know that where the curve changes its curvature, means such as for example from concave to convex or from convex to concave. So in this situation, graphically we will have a curve like this. So the point of inflection will be, usually we calculate through the equations, but as we see the curvature is changing, means from this, you can see from here the curve is this, and now it becomes it is changing here. So this will be the point of inflection. You can calculate in equations, and this is our relative maxima, this is relative minima. So, and this is absolute maxima, absolute minima. Now here this is the point of inflection because our curve is changing its curvature from concave to convex. So this is our point of inflection. And now let us see some examples. First problem or examples is y is equal to 7x square plus 126x minus 23. So let us find the solution. Will be, first we will differentiate, first order differentiation. So we will do dyx will be 7 into 2 will be minus 14 to the power x plus, so it will be 126 is equal to 0, or 126 equal to 14x, x is equal to 126 by 14, it will be 9. Now our x is 9. Now the second, we will do second order differentiation. So the second order differentiation will be, it will be minus 14. When we differentiate this one, this equation, when we differentiate again, so it will be minus 14, which is negative, which is less than 0. So this is the case of our first is positive, and the second is, first differentiation is 9, x is equal to 0, while the second is negative. So in this case, because all the situations first differentiation will be equal to 0, this is the condition. Now just we have to find the second differentiation. So our second differentiation comes out to be negative, which means it is a case of maxima. Now let us see another example, problem second. We have to find the minima or maxima. 3x cube minus 36x square plus 135x minus 30. This is so we will first do first differentiation, dy will be dx. 3 into 3 will be 9x to the power 2. 36 into 2 will be 72 power x plus 135. So it will be equal to 0 as our first condition. So now x, when we differentiate it, now take the second differentiation. Second differentiation will be, first find out the x. Okay, let's find out the x. So using algebra, we will take out 9 is common, so we will take out 9 out, minus 9 8x. So it will be 9 45, so it will be 15. We take, so the equation left to us is 8, this. Now we will using the algebra rules by dividing the equation, this 8x as 3x minus 5x. because when we add this it will be 8, and when we multiply this it will be 15x square. So both these terms we divide this plus 15 is equal to 0. Now take x out from this, x minus 3 minus 5 and x minus 3 is equal to 0. So the first is x minus 5 and second is x minus 3. Now our x will be 3 or x will be 5. Now the second order we will do the second order differentiation. So second order differentiation will be 18x minus 72. When x we have differentiate this, 9 to the 18x minus 72. So let's put the value of x in this. So because we can't know with this, we don't know whether it is positive or negative. So for that we put the value of x, 18 into 3 minus 72, 24, 54 minus 72, it will be minus 28. It comes out to be negative, so this will be it comes out to be negative. So this will be the case of maxima. And if secondly, if we substitute the value x is equal to 5 in the equation, so 18 into 5 minus 72, 6, 7, 8, 9, it will be 90 minus 72. So this comes out to be 18, which is greater than 0. So in this is the case when x is equal to 5, y is at minima. And so this is the case of minima when it is positive. So we conclude that when x is 5, y is at minima, and when x is equal to 3, y is at maxima. Now we will see equation 3. So the problem third, it is y equal to x cube minus 3x square plus 5. We will do first differentiation. So 3x square minus 3 to the 6 to the power x. So in this case we know it is equal to 0. We will find the x. So it will be 3 to the we will because 3 is common, 3x, we will take out 3, x minus 3, 3 to the x minus 2, x minus 2. So first is our x, one is x is equal to 2 and second x is equal to 0. Now we will do second differentiation of this equation. 3 into 2 is 6x minus 6. So through this we also can't able to know whether it is positive or negative, so we have to substitute the value of x in this equation. So first we will substitute x is equal to 2 in this. So when x is equal to 2, 6 into 2 minus 6 to the 12 minus 6, it will be 6, that is positive, means this is a case of minima. When x is equal to 2, the y is at minima, and when x is equal to 0, so let's see, 6 into 0 minus 6, 0 minus 6, it will be minus 6, so it is negative, means when x is equal to 0, y is at maxima. So here we solve this. Now let us see another example. Problem 4. Problem 4 is to the power 4 minus 10x cube plus 6x square plus 5. So we will first differentiate it using first differentiation. 4 into 3 is 12, x to the power 3 minus 10 into 3 is 30, x to the power 2, 6 into 2 is 12 to the power x. So we are not able to know, we will do algebra and we will take out some common number, that is 4 is common, so it will be 15 fours. There is a mistake. No, we will differentiate it later. First we will do second differentiation, so it will be easy to differentiate to find the value. So we will do second differentiation, so it will become 12 into 3, it will be 36x square minus 3 into 2 is 60x plus 12. So now we will differentiate this equation and 4 is common, so we will take out the 4 minus 15x plus 4. So, or it would be okay if we can't do so because this is not equal to 0. This we don't know about this, so we have a doubt. That's why we can't do so. We will do algebra on the first equation. So we'll take out the common number from this. So in this x and 2x is common, so 2x will be taken out. 6x square minus 15x plus 8, it will be 0, because we know the first our condition is first differentiation is equal to 0. Now 6, it will be cancelled, so 6x square, we will divide this 15, it will be 8x minus 6x plus 8. We will take number in such a way that if when we multiply 8 into 6, 8 into 6 is 48, 40x square, so it will be 40x square, and when we add this it will be 15x. So in this we divide this. Maybe you have all have known about the algebra, so no need to explain. Now take out common number from this, so 2x will be taken out, it will be 3x minus 4, and from here also 3x minus 4 will be common, minus 2 will be taken out. Now 2x minus 2 is first and 3x minus 4. Let us divide, so x is equal to 2 divided by 2, it will be 1, and another x, this x will be 4 by 3. So now we will put the values in the second differentiation. We will put these values in our second differentiation, that is 36 when x is 1, when x is equal to 1, so 36 into 1 whole square minus 60 into 1 is 60 plus 12, so it will be 36 minus, so what happened, we will do minus 60 plus 12. So let's calculate. When we deduct 60 from 12, 1 minute, minus 12 will be 48, so it will be 36 minus 48, and this 48 minus 36 will be 12, So it will be minus 12, that is negative. So it will be the when x is equal to 1, y is at maximum. We can see in a graph also. We can draw x and y axis, and we'll put the value of x is equal to 1 and y is equal to minus 12, and we can show. And now the second value is x by 4 by 3. It will take time, so you do it yourself. And now that's for today. Thank you so much. And if any question, you can ask in the comment box.